Good evening, children. I hope everyone are doing fine. Let us continue with the chapter 5, that is periodic classification of elements. So today we are going to looking at the topic trends in the modern periodic table. So let us begin. As we all know, in the periodic table we have two divisions, that is periods and groups. So here in the periodic table, as we know, 7 rows is known as periods and 18 columns known as groups. So what is periods? So elements in the same periods, the elements which are present in the same periods have same number of shells in their atoms as well. So shells are nothing but, we can otherwise call it as orbits. Example, sodium and magnesium belong to same period, that is 3. So sodium atomic number is 11, that is electronic configuration we can write it as 2, 8 and 1. Okay, and magnesium atomic number is 12. Okay, so electronic configuration is 2, 8 and 2. So both have 3 shells, so they belong to the period 3. That means electronic configuration is 3, right? So that means they belong to the same period, that is 3. Example, potassium. So what is the atomic number of potassium? That is 19. So how can we write the electronic configuration? That is 2, 8, 8 and 1. Calcium atomic number is 20. So electronic configuration is 2, 8, 8, 2. So it belongs to the 4th period because number of times you are writing electronic configuration is 4. So it belongs to the 4th periodic table. First two elements are said to be the shortest period. Okay, and second and third period, it consists of 8 elements in total. Okay, that is said to be short period as well. Fourth and fifth, it consists of 18 elements, so we call it as long periods. You can observe in the modern periodic table. Sixth, that consists of 18 elements and more 14 elements are placed below, which belong to the 6th row itself. That is totally 32 elements. So that is said to be a longest period. And 7th period, it is an incomplete period. Okay. So coming to groups. Groups are the column of the periods. Okay. Elements belonging to the same group will show same physical and chemical properties. Fine. So the elements which belonging to the same group will have same physical properties as well as chemical properties. So the group number indicates number of valence electrons. Okay, how many electrons will be there in the outermost shell? That is said to be valence electron. Okay, that is there in the atom of an element. Example, sodium atomic number is 11. So how can we write the electronic configuration for sodium? That is 281, which belongs to the first group. That means the valence electron in case of sodium is 1. 2, 8 and 1. So which is the electron in the outermost shell? That is valence electron, that is 1. So sodium belongs to first group. So next example we shall look on magnesium. So what is the atomic number of magnesium? It is 12. So what is electronic configuration? 2, 8 and 2. Okay, it belongs to second group because the valence electron is 2 in case of magnesium. So next example, that is aluminium. So aluminium atomic number is 13. So electronic configuration is 2, 8 and 3. It doesn't belong to the third group because I'll be explaining why. So because there we have transition elements and normal elements. Okay, so it has named as 3A and 3B. Okay, so this belongs to 13th group. Okay, so group 3 as a transition element. So aluminium is placed in group 13 because aluminium belongs to the normal elements, so it is grouped there. Okay, and here in group 3 all are placed as transition elements. So that is the reason aluminium is taken to group 13. Okay, so carbon 6th element, it is a 6th element, so electronic configuration will be 2 and 4. Since the valence electron is 4, it belongs to the group 14th group because carbon belongs to normal elements, it is not a transition elements. Okay, next is chlorine. So chlorine atomic number is 17. So electronic configuration will be 2, 8 and 7. Since the valence electron is 7, it belongs to 17th group. Okay, so valence electron in the atoms of element ranging from 3 to 7 will belong to the groups 13 to 17. Okay, whatever the valence electron in the atoms which ranges from 3 to 7, it will belongs to the group 13 to 17. Remember this point. Okay. So coming to group 1, all elements are called as alkali metals like lithium, sodium, potassium, rubidium, cesium, francium. All these are said to be alkali metals except hydrogen. Okay. So alkali in the sense which are water soluble bases, which are water soluble. Okay. So except hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, all these are said to be alkali metals, which is said to be group 1 elements. Okay. So coming to group 2 elements, so these elements are said to be alkaline earth metals because they are oxides. So when they form oxides, these are obtained in the nature and it is present in the nature, alkaline in the nature, but it is obtained in the earth. So we call it as alkaline earth metals. Okay. So next is group 16 elements. So they are called as chalcogens. Okay, why they are called chalcogens? Because they usually found in ores of metal. So you know what is ores, right? So usually they are obtained in the form of ores of metals like oxygen, sulfur, selenium and tellurium and polonium. All these are said to be chalcogens. So I didn't read out these elements, that is group 2 elements, alkaline earth metals, that is beryllium, magnesium, calcium, strontium, barium and radium. Okay. Next is group 17, that is called as 7A elements are called as halogens. So halogens reacts with metals to form halide salts, that is fluorine, chlorine, bromine, iodine and astatine. These are said to be group 17, that is 7A elements. Next coming to group 18, that is 8A elements are called as inert gas elements. So what are inert gases? That is helium, neon, argon, krypton, xenon and radon. These are said to be inert gases. Okay. So next coming to periodic table of the elements, you already know the arrangement of elements in this table. You can see hydrogen. So why it is placed at the top? Because the valence electron is 1. So it is placed in 1. Okay. So first group it has placed. Okay. Next is helium. It is having a 2. Right. So it has fulfilled its duplet form. Okay. So it is placed in the first group itself. Okay. So these are the divisions you can see, wherein as I said the transition elements is given as 3B, 4B, 5B, 6B, 7B like this. So till 12. So wherein the normal elements they are given as 3A, 4A, 5A, 6A, 7A. Right. So it depends on the valence electron and that is how they place it in periods and groups. Okay. So this was a concept about trends in modern periodic table. I hope you guys have understood the topic. Okay. So I'll be sending the worksheet, children. Do solve it and have a good day.